Hi, my name's Troy McGuinness from deliverytower.com. In this presentation, I want to talk about how to measure AI engineering performance. Now, fast isn't the hard part anymore. With AI engineering, we can deliver code at much faster than we could before. And that code is often of varying quality, depending on how we've looked at it. Now, what I want to teach you in this session is how to measure AI engineering performance so you can move at a speed that your teams can verify. Let's get started. Now, it's very easy. Often when people set out to measure performance, they start measuring visible activity, lines of code generated, tokens consumed, pull requests open, cycle times reduced. Now, the problem is any development system worthy of customers purchasing something, there's always a constraint. And it doesn't matter that you 10x one part of your team, in this case, code generation, if it's going to be blocked and stuck in the go-to-market activities. So visible activity is easy to measure, but often misleading. Now, what we want to try and move to is a way of measuring outcome metrics, things that actually have an impact on the customer. Customer value is improved. The strategic work that the company wants to deliver is delivered. And when we deliver it, there are fewer regressions, fewer review surprises, and less remediation work. So often what we want to look at is winning indicators for using AI engineering. And that could be things like that your constraint now might be your review capacity. You might have tons of open pull requests ready to review. But what you want to make sure is that the right work is being reviewed and the right pull requests are being opened. So the right work is being delivered, and that's increasing. The open age of those pull requests for the right work should be declining. Now, that's not all work. If a pull request is intentionally skipped and left open while more strategic work is reviewed, that is a good thing. So don't go measuring PR open age and trying to reduce it across the board. Look for it for the work that you want to deliver. Pull request review merge friction. Now, often AI can generate the code for a pull request, but then there's a lot of back and forth with those go-to-market activities, and it didn't really stick to our architectural decisions and so forth. So what you want to look at as a way of maturity is that those merge friction signals are reducing over time. The company is learning to use AI engineering well, not just learning to use AI engineering at all. Now, what thing you want to really make sure is that often if there's a ton of pull requests, they might be merged prematurely. And the way you would tell that is the quality declines. So if you want to see rollback and remediation work from those pull requests declining over time, as AI learns to code in a way that's acceptable and of high quality. And the big lesson that you want to take from this presentation is that over time, we want to increase the percentage of work that is safely handled by AI without requiring a ton of human input. And I call this percentage of low-risk work safely handled by AI. And what we're trying to do is we're trying to make more work in our organization lower risk so that AI can deliver it safely. So there are 5 measures that I think are winning indicators for AI adoption. Now, what we're really doing is the old bottleneck was, can we build it? We used to be very particular about what we chose to start because what we started was we could get a fraction of that delivered. But now with AI engineering, we can get we can build anything really. We could sort of send it out, create a prompt and set it loose. But the new bottleneck is, should we build it at all? And if we build it, can we verify it? And there are many factors that sort of move into that new bottleneck. Is it understood at all? If it's not understood, it doesn't matter what you hand off to AI, it's still going to be not understood and probably go off on a tangent. Is it strategic? Is it verifiable and safe to implement? Does it sort of break some core library that's used by every part of the application? So we need to measure at the bottleneck and understand what's there. Now, in this case, I roll these 5 dimensions into an AI deliverability score. Is it strategic? Is there customer value in it? Do we understand what's wanted? Is it verifiable? And is it safe to implement? Does it have a huge risk to the rest of the platform? Now, performance in AI engineering is really understanding and being able to tell up front these factors before you hand it off to AI and have a disaster down the line. And what we're really trying to do as a superpower is take the work that we've delivered historically using AI and learn from it and improve these factors up front. So not all teams are going to want to use these dimensions in the same way. And here I've broken some of those dimensions out into smaller aspects of those dimensions: strategy, value, priority, clarity, verifiability, safety, and AI fit. And each team in your organization is probably going to want to drag these sliders slightly differently. And why does that matter? Because unless we understand the weighting towards each of these dimensions, what we don't really know is how to order our backlog of work we should send to AI and what order to merge pull requests once they're opened. So what I've built with deliverytower.com is a way of assessing backlog items across these dimensions, letting you set these weights and get a prioritized list of work that you should start, analyzing the open pull requests for lessons that historically have caused problems, and then once we merge pull requests, take the lessons we learned from that merge and feed it back into the scoring mechanism next time. So these are split into two areas. One of them is understanding whether we should start it based on value and strategy. And one of them are gating factors that sort of says, if these aren't high enough, it doesn't matter if we hand it to AI, it's going to be a disaster when we try and merge and deliver. And knowing between the two, being able to identify up front what work falls into which bucket is the core skill of you're trying to measure with your AI engineering performance. So this feedback loop that we want to build in, it used to be built into humans. We used to review pull requests, and then the developers would learn about what they missed or what they did wrong, and next time not make the same errors. The problem is with AI engineering is often we move so fast that we never go back and retrain the AI coding engine with skills or rules how to avoid those future problems. And we do small parts, but we don't do a lot of it. And what we certainly don't do is add in and learn from when we do this type of work, what do we have to particularly pay attention to when we review? And what factors are outside of the dev team in the go-to-market activities that we need to prepare for? And this is what Delivery Tower is trying to do. It's trying to make a continuous learning platform based on delivery of work so that up front you understand what work you should start, what work you can start, and how to make sure you get an ever increasingly growing percentage of work that AI delivers with very low friction in the merge and the delivery. So I think the bottleneck moves from the developer coding and the creation side of it into the reviewing the risks and prioritization. So one thing that I do in Delivery Tower is I help you score open pull requests to understand what order they should be merged based on different factors. And those factors come out of prior historically merged PRs that have gone poorly. So we learn from merged PRs the friction, the comment volume, how aggressive the sentiment was in those comments, the change profile, what files it touched, how big the change was, to predict a change fail rate that help you understand which ones you need to pay more attention to and less attention to. And also that we get a set of lessons and review suggestions that mean that we know what to check when we do get faced with a PR based on historical lessons. What's an example here? So one of the features is that you can point Delivery Tower at an open source project. In this case, it was ShadCN, the UI library that's really cool. But here's an example of a fix that was a registry fix that ended up having zero code change, in fact. But it was incredibly hard to merge. And what Delivery Tower does now is anything that has the same change profile as this fix, it knows to give a high risk score to up front so that you can prepare for that world. So what good looks like in using AI engineering is that more of the work in the system moves from the right to the left. In other words, things that are very high risk, we start dealing with rules and processes in our AI engineering to make them less likely to fail when they get to merge time. So as teams get more mature, more work goes down into the high score for safety route as AI first code. So again, here's an example. Simple is not easy. So a very small, trivial zero code change really struggled to be merged. And it's about knowing these signals in advance that helps you plan and prioritize the risk that means that this work should go AI first. So because it just looks simple in the change size, doesn't mean it's simple in delivery. And Delivery Tower helps train and maintain a model of what type of work we struggle to deliver to, even though AI can develop the code very quickly. It's all about learning from those errors. So try out deliverytower.com. It's going to help you score issues up front and learn from delivery of other issues that are similar to that so that you can understand their risk and priority up front. If you have any questions, just email me, troy@focusobjective.com, and I look forward to working with you on understanding your issues. Thank you.